we present TriPlaneNet, an encoder for EG3D inversion. Given an input image, GAN inversion techniques try to infer the latent code in the GAN space that represents the input image in the best way. Compared to 2D GAN inversion, doing the same in 3D is a challenging task, as the inversion needs to both preserve the identity of an input image and satisfy the 3D consistency constraint in generated novel views. State-of-the-art optimization-based methods perform very well for 2D GAN inversion. However, when applied to 3D GANs, they often fail to preserve identity and 3D geometry in the novel view and are time-intensive. Exposed to a large number of images from arbitrary views during training, encoder-based approaches learn to preserve 3D geometry and are faster, but they fail to preserve fine details of the input image. Our method, TriPlaneNet, tackles these shortcomings by directly utilizing the triplane representation in the EG3D pipeline. Given an input image, in an initial phase, we utilize an encoder to predict pivotal latent code, % in the space of EG3D. In the second phase, we take the corresponding initial reconstruction and its difference with the input image and process it with an autoencoder to estimate triplane offsets. The offsets are numerically added to the triplane's output by EG3D generator. The final reconstruction is obtained by processing the refined triplanes by the renderer block. We additionally make the encoder more 3D aware by applying probably symmetric prior inspired by the work by Wu et al. In the first phase, we render the head from a mirror camera view and compare it to the mirrored input image by a weighted penalty. The weights are defined by an uncertainty map, where higher confidence is given for the pixels that are more likely to be the same as in the mirrored image. The loss is applied to both branches. We compare the same view reconstruction results of our method with existing state-of-the-art inversion techniques, including encoder-based and optimization-based, for the human facial domain over the Celeb AHQ test set. Compared to other approaches, our method can reconstruct a face in the same view with a high level of detail, on par with the best optimization-based approaches, while being significantly faster. For novel view rendering, our method preserves identity and multi-view consistency similar to the best optimization-based approach SPI. However, our method embeds the head in the 3D space better than all the other approaches, which is indicated by the depth metric in the paper. Our inversion framework also allows for extracting accurate 3D meshes by marching cubes from EG3D implicit representation. To further analyze PTI and triplane offsets behavior, we designed different hybrid two-stage inversion approaches that combine both optimization and prediction, and compare them with our method. With just latent code optimization, 3D geometry is stretched in the wrong way, which is observable from novel views. Latent code optimization followed by generator parameters optimization experiences the same issue. When combined with the triplane offsets prediction by our method's second branch, the damage caused by W+ optimization in the first stage is partially alleviated. Latent code prediction by an encoder, however, handles the head geometry better but does not preserve identity as well as PTI does. This can be explained by the supervision from multi-view images during the encoder training. Applying the generator parameters on top of the latent code prediction harms the geometry. Optimizing the triplane offsets, on the other hand, maintains high reconstruction quality and preserves 3D geometry and identity in a novel view, but is prone to visual artifacts. Our method reconstructs fine details, preserves 3D geometry and identity when rendered from novel views, and reduces artifacts compared to the optimization-based approach. Adding the symmetric prior allows for a larger region of the head to be reconstructed. As an application, our method can be utilized to re-render in-the-wild videos from a novel view when applied frame by frame. The framework is capable of representing tiny details of in-the-wild portrait imagery in 3D and supports complex facial expressions. Thank you for your attention.